Well, good evening, all. Another round of meteorology lab here, and another boring September day here in Texas. Of course, that is going to change pretty soon. May take a week or two, but we'll get there. But looking off to the south here, looks like some thunderstorm anvils. You see how mushy they are? These are kind of weak anvils. And you can kind of see them on the satellite picture here. See down here in the College Station area and just west of Houston. That's looking down that way and checking those out in the distance. And this is what they look like a little bit earlier. If I can get it to, yeah, there we go. So check out the anvils. Notice which way they are spreading. See, there's kind of a plume shape kind of like this. So that tells us that the winds are out of the north. We can see that here on the SPC 200, where are we at? 300, yeah, 300 millibar analysis. So this is up at 30,000 feet, almost at anvil level. And that's showing the northerly flow across much of Texas. And the purple shading is divergence. That can be from speed divergence, or that can be from diffluence of the wind flow, where you have wind spreading apart. In this case, it looks mostly like speed divergence taking place there. So that could factor in a little bit into this area of storms here. Maybe it kind of aligns with this area of upper level divergence. And all this is being caused by this upper level high that's centered over the Monahans and Midland area. And maybe I'll show that to you, because I was kind of sitting here thinking, you know, things are really boring. What can I show the listeners? So let me show you a little something out in Texas that's kind of interesting. I don't know how many of you have been out to West Texas, like west of Abilene or west of Junction, but there are actually like sand dunes out in that area. I think there's one in the, see, I'm not too sure how far up and down the highway it is. It's somewhere west of Odessa. There's like sand dunes right near Interstate 20. And yeah, it totally escapes me exactly where that is. It might be in the Monahans area, but they actually look like sand dunes from like the Death Valley of California. And this is the southeastern part of New Mexico here. See that right there? There's a little border spot. And a lot of this is very sandy terrain. I went out there and planted a geocache many years ago, and yeah, there's just tons of sand out there. But apparently it's very good for oil drilling there. So anyway, at least I guess they can do something with the land there. So let's go back to our weather here. Here's the streamlines for the United States. This is the surface patterns, looking strictly at wind. So what do we see here? This pretty much tells us high pressure over Missouri. So we're getting that clockwise flow around that high. Now, another thing that's very important that we're seeing on this chart is boundaries, like especially fronts and convergence lines, confluence lines. A good example is out here in Nevada. See how the wind is coming together out there? This is pretty significant because this suggests that we have two different air masses coming together, and that is the very definition of a front. So we can use streamlines to help find fronts. So without even looking at the surface data or even looking at the thickness charts, we get a rough idea where we should be looking at. So basically from west of Salt Lake City to around Ely and down to Bakersfield, California. Another possible area is going to be up off the coast of Washington. See right here? That's definitely a possible location for a front. And another spot looks to be through the Delmarva area. See, we have these southerly winds coming up across Norfolk. and maybe a very slight change in the wind direction up here in New Jersey, so that suggests maybe that there's a front through here. And actually what I'm seeing here is what we call, let me just draw this out real quick. See that right there? That's a deformation zone. Let me draw that out in full here. And I better check over to chat to make sure the mic is on and everything sounds good and no complaints, so I guess we're good there. But anyway, so let me finish drawing this out. You've probably seen this in textbooks, and here's a classic case of that. Oop, I actually went the wrong way with this. Sorry about that. That actually goes like that. This goes that way, that's correct, and this goes that way, and this goes that way. So that's a deformation zone centered on Pennsylvania. And so what that's telling us is we have an area of divergence right here across Michigan, another area of divergence across Delaware, and then we have convergence across Kentucky and the Ohio River between West Virginia and Ohio, and another convergence zone through Connecticut and Rhode Island. And I've used that on occasion to help find initiation areas for thunderstorms, because a lot of times this will correspond to a frontal boundary. So when I see that, I'll forecast possible thunderstorm development here and not so much in this area here at the center of the deformation zone. Okay, so that's our look at the surface charts. So now we can dive into the models and stuff like that, and we'll have a pretty good idea what's going on. Looks like probably another front up here along the Canada-US border. See that right there? Just barely shows up, but we definitely do have a difference in air mass origin right there between Montana and Saskatchewan. So going back to the radar, this is just a quick look at what we were seeing earlier. There's those cells near College Station, and again near, I guess, Sugarland or Roseland. I don't know that area too well, but those storms do look on the non-severe side. And why do we have those storms? Well, we've pulled together a little bit of instability. This is the Fort Worth sounding, and you can see that it's uncapped. There's maybe a little bit of capping right here. So if we try to lift this parcel of air, say that temperatures get up to about 90 degrees, our lifted parcel is going to look kind of like that. And it does look very uncapped, so I guess the question is, why do we not have more widespread thunderstorms? That's a good question. I guess we may be mixing some of this dry air here. This is around 7,000 or 8,000 feet. That might have mixed down to the surface and kind of kept parcels from reaching their LCL. So that's probably my best guess. You know, there's definitely dry air right off the surface. Let me bring up the evening sounding real quick for Fort Worth. I'm back in digital atmosphere here. And let me see if I can get that going. There we go. There's the 0Z sounding, so this is 1 hour ago. And the moisture does show that it has dried out a little bit. So the parcel lifts are looking like this. And that's showing just a little bit of capping right here around 10 or 11,000 feet. So for all I know, that may be the reason. Maybe we were just a couple of degrees too cool, a few degrees of dew point too low to really get things going. But not a whole lot of instability on tap up there. This is like 500 to 600 Cape. Okay, looking around elsewhere in the country, here's tropical depression pain along the coast of Baja California. That's throwing a couple precipitation bands into the San Diego area. Maybe I can find a couple of advisories on that. Tropical depression pain. This is going to be the track over the next day or two, and they're forecasting a low likelihood of tropical storm wind speeds in the inland areas. But probably a lot of rain coming into the desert areas of Arizona there later this week. In the other tropical systems, there's Carl again in its drunken wanderings across the Atlantic Ocean. I don't know what its track has been, but it's probably something like that. And now we find it closing in on Puerto Rico, and I wonder which way that's going to go. They don't have a forecast outline for that storm. Well, maybe I can pull it up down here. Yeah, there we go. They're still going for some recurvature here. So there's the movement on that. Looks like that's going to graze Bermuda here. And what day is that going to be? About Friday or Saturday there. So eventually it will be out of the picture, but we're going to see it again tomorrow and the next day, I'm very sure. And this is that other storm coming on shore. I've already forgot the name. We saw it on the Carolinas coast yesterday, and now it's inland, and we're getting a lot of just disorganized precipitation and showers into the Norfolk and Hampton. Is it Hampton Roads? I forgot the name of it. And I guess Langley Air Force Base is there, and that's about the extent of my knowledge of geography there. I guess Richmond is right here and up to the north, and that's about all I know. So it looks to be wet, probably in the Delmarva area over the next day or so. So time to check out the forecast. We'll go to the GFS panel here and look ahead. So starting for today, here's the big Pacific high, driving some cool Pacific air inland. And we are expecting probably a little frontal boundary through here. Remember, we saw that on the streamline charts. So we'll keep an eye out for something in that area, maybe coming together. There's the remains of that old tropical storm off the Carolinas coast. Now we'll move forward. So now we're up to Thursday. The remains of pain is coming into the Yuma and Needles area. And now we start seeing high pressure building across the Dakotas. We've seen that signaled in the model forecasts over the past few days. So that's going to be the story over probably the lead into the weekend. And obviously some showers and thunderstorms along that boundary in Minnesota and Iowa and the Dakotas. So let's see, going through the weekend here, very deep tropical flow across Texas and all the way up to Manitoba. So we'll probably see the sea breeze become a little bit active over the weekend in Texas. And then we start seeing this high pressure starting to build across the northern Rockies right here. See that big high? And there's a lot of cold air advection coming out of Wyoming and Montana. And the models have actually gone a little bit stronger with this compared to last night. There's more of a drive of cold air into the central U.S. And it brings that front into Texas on Monday the 26th. So that's going to be about 6 days away. And more high pressure up in the Alaska area for probably next week. So high pressure takes root over the southern plains, and the strong, well, not strong, but this week northerly flow across Texas and the considerable moisture here, that tells me good possibility of a rainy pattern in Texas and Louisiana for next week. That's kind of that overrunning, dreary picture that we sometimes see in the fall. And then we're still looking for a big polar outbreak. You remember yesterday we were looking at October 3rd to 4th through that? The models have backed away from that again. I think there's probably a cold bias once you get out past 330 hours. Because now, here's the big outbreak of air. It looks more Pacific actually, and this is October 6th. So I think most of the panels past 240 hours are probably bogus to a certain extent, so we'll just consider that part of the crystal ball package here. And I think that's the last frame I have. So let me look over, see what's going on in the chat, and things look pretty good there. I got 9 people checking things out this evening. So hopefully we'll have some stuff to look at tomorrow. I appreciate you tuning in, and I will see you at the same time tomorrow evening. Thanks.